So welcome to day 2 of our AP Precalculus review. And yesterday we discussed about problems 1, 2, 3, and today, April 23rd, we're gonna discuss problem number 4. Now there are problems in the actual actual AP Precalculus test which don't require solution. All you have to do is just analyze the problem, okay? So in this case, we're gonna analyze this one. The problem says, which of the following statements about the tangent function is true? Okay, I'm gonna draw first tangent function. Remember, a tangent function, for the parent graph of a tangent function, we have a tangent graph is inclusive or in between the two vertical asymptotes, right? So we have this vertical asymptote and this vertical asymptote. So it's in between the two vertical asymptote. And then we have the graph of, it will cross right here at the origin. Okay, so that is tangent graph, right? Tangent function graph. Of course, if we continue on the left and if we continue on the right, the same pattern. So what you notice on this one? So again, it is inclusive with the two vertical asymptotes. And how about this graph? Now, what is the concavity of this graph right here? What is the concavity? Concave down. And right here is the point of inflection. After the point of inflection, this is, what is the concavity? Up. So, but what kind of function is tangent function? Is it increasing or decreasing function? Increasing function, right? Okay, so we have the options right here, and I'll go backwards. Let's take first on option D. Now, again, these are the info. This graph serves as an information about tangent graph, right? About tangent function. So, letter D, the tangent function decreases and its graph changes from concave up to concave down. So, I'm gonna have decreases. Is the graph decreasing? Increasing, right? So, we're gonna choose this one, right? We're gonna have to do and then the tangent function, letter C, the tangent function decreases and its graph, so still mention on decreases, so we cannot choose this one. So the only possible options right here, our candidate is A and B. And let's go to letter B. The tangent function increases and its graph changes from concave up to concave down. What is the behavior of the concavity? Concave down to concave up. So this one changes from concave up to concave down, but it's not, right? Okay, because this is concave down, and then concave up. So therefore, letter A is the right answer. Tangent function increases. Is it increasing? Yes. And its graph changes from concave down to concave up between consecutive asymptotes. These are the consecutive asymptotes, the red color. Okay? So this is the right answer. Letter A is the right answer. Any question, guys? So does it require mathematical solutions, but we're gonna analyze, okay? Any question for number 4? So let's move on to number 5.
Thank you, Mr. Roy.
You're welcome, Miss
I'm
Cruz.
so sorry. My daughter just told me in the morning, she's like, Mom, I have a new word today. I'm like, what? So thank you, Mr. Roy.
You're welcome. Okay, can I erase this now? Okay. So let's move on to number 5. Which of the following must be true? So it's asking on the true statement, right? It must be true. Absurd. So for a logarithmic function, y equals a log of x base b, where a is the non-zero constant. So, any idea about the graph of logarithm? Okay, let's take a look on the graph. I'm gonna share 2 graphs right here for us to analyze. Okay. Now, we're gonna consider a logarithmic function. 2 graphs right here. So the first graph is, this is logarithmic function graph, right? And another graph of logarithmic function is this way. Now, okay, it says the limit as x approaching the right of let's have this, the right of 0, okay? Look at the graph. So a log of x to the base b is equal to 0. Is it 0 right here, left of 0, or right of 0 rather, because it's plus, right? The right of 0, is it equal to 0? Yes or no? Look at the graph, the behavior of the graph. Is it equal to 0? Yes, no? No. Okay, how about here? Is it equal to 0? It's gonna be right of 0, so we cannot choose this, right? Am I clear, guys? Okay, because it's not equal to 0, but it's gonna be positive infinity, right? And on the other graph, this is negative infinity. Okay, so letter B, still on the right of 0. The limit of a log of x base b as x approaching the right of 0 is equal to 1. Is it equal to 1? Is it equal to 1? It's not. Okay, it's not. Okay, you get me? So both the first and the second graph. Okay, next let us analyze this one. The limit as the limit of the function a log of x base b as x approaching positive infinity. Approaching positive infinity. Is it equal to 0? So this statement is a false statement, right? Okay, next. Let's do letter D. The limit of the function a log of x base b as x approaching infinity. Look, as x approaching infinity. Okay. Positive infinity, meaning to the right. Then what happens to the graph? Is the graph on positive infinity right here? Yes, no. Is the graph on negative infinity right here? Yes, so plus and minus infinity, right? Positive and negative infinity. So D is the right answer. Please feel free to ask questions, guys. We're gonna analyze, okay? So don't panic during the actual AP test. Just relax, and if you think it's hard for you, just skip that first. Proceed to the next question. And then once you're done everything, you go back to the questions where you struggle, okay? Any question, guys? Okay. Can I erase now? Done? Okay, let's have number 6. It says, which of the following represents the graph of the function r is equal to f theta, okay, where the given function f of theta is equal to 4, and then sine theta plus 2. Now, by looking at this, what function is this? Sine function, right? And we know that the graph of sine function is along the y-axis. So you get me? And the graph of the x function, if it is polar coordinate, it's gonna be on the x-axis. Do you get me? So therefore, test taking strategy. Let's have letter C. Can we choose letter C? where do you think is the graph? Is this on sine or cosine? This is cosine. So we're gonna knock this out because that graph is along the x-axis or cosine, right? So the cosine is on the x-axis and the sine is on the y-axis. Okay, next. So what are the possible candidates right here? Possible candidates for sine, we have A, then B, and then D, right? But we already knocked out letter C because this is the graph of polar function, which is cosine. Okay, polar. So let's have plus 2, or when we say 4, that means we're gonna have to count how many circles. Okay, so it must be 4 units. But the thing is, can you count how many circles are there for this one? 5. And then, so we cannot choose this one because it must be 4 from the origin. But because of this, plus 2, that means there is 2. Okay? So we cannot choose letter B. We cannot choose also this one. But this one, it has 2 circles, right? This is plus 2. And then after that, we're gonna have 4 units. 1, 2, 3, 4. So A is the best option. Okay, so moving on to problem number 7. So same thing, we don't have to solve, but we're gonna analyze. What are the vertical and horizontal asymptotes? So this is a rational function, right? Y equals 6 over x plus 5 and then plus 7. Rational function. Okay. It says vertical. What are the vertical and horizontal asymptotes of the given function? Now when we say asymptote, so we're gonna have the x domain, right? The domain. So in this case, what must be the value of x that the denominator is 0? We have the denominator right here, x plus 5. So what particular number that the bottom or denominator gives us 0? So that we can have vertical line. Okay? Vertical line. What must be the possible value of x that this bottom is 0? It's gonna be what? Okay, -5. So, test-taking strategy. Again, test-taking strategy. We all know that x must be -5. Is A a candidate? What is x right here in A? 5. So, A is not a candidate because we're gonna have the value of x as -5, right? So, possible candidates, B and C, test-taking strategy. Then D cannot be a candidate. So we have B and C as the option. Next, we can analyze. So these are both correct in terms of the value of x. But let us have horizontal asymptote. Now, For horizontal asymptote, we're to look into the horizontal asymptote. Can you look at this as horizontal asymptote? I'm gonna choose another color. Okay, this is the horizontal asymptote. What is that 7? Positive or negative?
Positive.
Positive. So what must be our best answer in this case? That y should be positive 7. Is this a candidate? No. Letter C is not a candidate. So therefore, y equals 7 is the horizontal asymptote. So letter B is the right answer. Any question, guys? Any question? So, but again, this is the right answer, right? We knocked out already because of this. So, and this one, of course, okay, letter B is the right answer. Okay, moving on to number 8. Okay, if sine x is equal to 4 over 5 and x is in between 0 to pi over 2, that means in terms of degrees, it's coming from 0 degree up to 90, from 0 to 90 degrees. Okay, that's what it means in terms of degrees, that x is in between. Therefore, the angle is between 0 degree up to 90 degree, or pi over 2. And what is cosine 2x? Okay, now I want you to know that what is sine in the trig function. Sine is the opposite side of the angle over the hypotenuse, right? If I draw that one, if this is the angle and we call this as angle x, so sine is equal to the opposite side. The opposite side of the angle is this side, right? So this is 4. And of course, the hypotenuse is 5. So you get me, guys? Okay? Sine is opposite over hypotenuse. So I'll write first sine x is equal to the opposite side, 4 over 5. Okay? You get me, guys? Now, next function, I'm gonna use green color. What is this right here as the unknown? Now, what is the next trig function after sine? We have cosine, right? Okay, what is cosine? The adjacent side over the hypotenuse. So we're gonna solve for the adjacent side. So what we do, remember Pythagorean theorem. If this is a right angle, sorry, I forgot. This is right angle, okay? Or else we're gonna do Pythagorean theorem if this triangle is not a right triangle. So now, do I have to show you Pythagorean theorem? No need. We had last time during geometry, and this is the 3, 4, 5 triangle, right? 3, 4, 5 triangle. That means this is 3. So get me, guys? So therefore, if we do cosine x is equal to the adjacent side. What's the adjacent side? 3, right? 3, and the hypotenuse is 5. Okay, take note of this. Okay, before we continue, any question? And we all know that cosine is 3 pi over, or 3 over 5. Now, remember it says 2 or cosine 2x. Okay, cosine 2x. So, what do you mean by that? We all know that cosine 2x is equal to sine square x minus, or cosine square x minus sine square x. Remember, we have double angle. Can you still recall the one? The double angle formula? Okay, so minus sine square x. Okay, so which means, what is cosine equivalent to? 3 over 5, right? So we say cosine 3 over 5 square minus, what is sine? 4 over 5. Okay, 4 over 5 square. So simplifying this, we have 3 square is 9, right? 9 over 5 square is 25, and then minus, we have 4 square is 16 over 25. They have common bases, so 25. This means 9 minus 16. But what is 9 minus 16? Negative 7 over 25. So negative 7 over 25. Now, what letter is this? And this is our answer. What letter? Letter D, right? Letter D is the right answer. We still have time. Any question, guys, on problem number 8? By May 5. What is May 5? Monday, right? May 5, Monday. And your test is May 13. We're gonna do the mock test starting May 5. That means during the class, you're gonna have to do actual or just a practice. It's a mock test for AP. So everybody should take the test without talking to each other. Okay, you're gonna have to do it by yourself. I wanna see how far have you been. Okay. So, shall we continue 9 tomorrow or just, it's almost time, right? Okay, so we'll just do number 9 tomorrow. Okay. So, thank you guys.